up guys, welcome to my new video, and today I'm going to show you how to stimulate an elevator using Beaglebone Black. So for that you need a kit which will look something like this, and it is having 7 direction LEDs, 4 position LEDs and 4 lift LEDs which will indicate from where the request is coming, and it will have 4 buttons for each floor. So we have four floors. The first one is the ground floor and the last is third floor. So this is the basic structure for the kit, and now let's look at the code for this. This is the code. You will have to define 5 header files for this. First one is file controller, second is fstream, which is for the file operations. Next is input output stream, next is ststream, and finally cstream. So these are the 5 headers. Next we will look at some of the definitions. So first we have defined 7 direction LEDs, which are these 7 direction LEDs. So we have defined these 7 LEDs, and we have assigned the GPIO number for them. Next we have made an array for this. So we have 7 direction LEDs in dir array. Next we have defined 4 position LEDs. We have made a array for this. Again we have button LEDs, which was the red ones. So this red LEDs we have defined in this array. We have also assigned GPIO number for them. Next we have array for buttons. So we have but as array for the button. Then we have defined a path, which is /sys/class/GPIO. Then we have a structure called floor, which has file descriptor, button and LED. So we have created a set for each floor, and we have initialized -1 as file descriptor for each floor. Next we have declared button. So we have initialized B1, B2, B3 and B4 for each floor. So B1 will be for the ground floor. Next we have red LEDs, which will indicate the request. So we have made a set for each floor. Next we have defined an integer called max file descriptor, which will be used in the select monitor. Next we have declared a set for the file descriptor called read for FDS, and finally we have a character called buff, character pointer, which is buff, which has only one memory. So next we will go to the int main. Where is it? So int main will call a function called exit all while. So let's go to exit all while. Where is it? Here. So what this function will do, this will initially set the value for the GPIO as 0. So what this is doing, so suppose someone else has used your Beaglebone. So there is a chance that he might have exported some of the GPIO pins. So for that you need to unexport all those pins which he has used. So that's what this function is doing. So it is initially setting value for the GPIOs as 0, and then it is unexporting all the GPIO pins. So it is calling a function called to_string. So to_string is taking an argument as integer. It is sending it to buffer, and then it is returning it as a string. So it is converting the integer to string in a sense. So next it is calling a function called GPIO set value. So let's go to GPIO set value. So it is taking 2 arguments, as for the one is GPIO and next is value. Then it is opening a file, and it is opening which file? It is opening the file called value, which is in /sys/class/GPIO number along with number, and then value, and then it is setting the value for that. So it is setting the value as 0 initially, and then it is closing that file. So in short, it is setting the value for the GPIO. Next, it is calling a function called GPIO on export. So let's go to GPIO on export. So it is taking argument as GPIO number, and it is again opening a file called /sys/class/GPIO and /unexport, and it is passing the GPIO number to it, and then it is closing. So in short, it is unexporting that GPIO number, GPIO pin, and it is doing this for all the direction LEDs, all 7 direction LEDs. Here it should be 7. Then it is doing the same thing for the position LEDs and button LEDs and button as well. So it is just unexporting all the GPIOs. Next, it is calling, it is again, the control will be in the main. After this function, it is going to init all by. So let's go to init all by. So init all by. So after unexporting all the GPIOs, we are exporting all the GPIOs again. So first we have exported all the direction LEDs. Then we have set direction for the direction LEDs, and we have set the direction as out. So let's go to set direction. So in set direction, it is again opening a file called /sys/class/GPIO, and then along with the GPIO number and the direction, and it is setting that direction to out. So we have used this sys_string. So what this does, this will convert this path to a C string, and it will in short make a array of characters, and it will insert a null character at the end. So it is just for converting it to a string, character string, and it is inserting a null character. Next, it is closing the file, and the control will return to init all by. So where is it? So after this, after setting the direction, it will set the value. So initially all the LEDs will be set to 0. The value for all the LEDs will be set to 0. Then so after doing for the direction LEDs, we will export all the position LEDs and button LEDs and button as well. So for setting the direction of button, we are setting it as in. So we are giving input to the Beaglebone, so we are setting it as in. And we have set edge for this button. So what is this set edge? So we'll go to that function. Where is it? So it is taking 2 arguments. First is GPIO and next is edge. So it is again opening a file called edge, which is in /sys/class/GPIO and /GPIO number, and it is setting the edge. So it will the trigger will be on the falling edge. So we have passed the parameter, the argument as falling. So the button will be triggered at the falling edge of the cycle. So for that, we have used this function. We set the edge as falling, and then we are closing the file. So after this, it will return to main, and it will declare 2 integers. One is called current and next is new floor. So this current will be for the current position of the lift, which is 0, and new will be for the new position. Then it is calling a function called open button. So let's go to open button. So here is the open button. So what we are doing in this function, so we are just taking the file descriptor for each and every button. So we have declared a set for each floor, which was floor, and it contained 3 things, which were file descriptor, button, and LED. So we have declared initially file descriptor as -1. So now we are taking the actual value of file descriptor in this function. So floor I, so it will initially take for the ground floor, next first floor, second floor, and third floor. So for floor 0, the file descriptor will be set to GPIO fd set, and this is a function, and it is passing the button for the floor. So let's go to GPIO fd set. So it is taking an argument for GPIO. It is taking the GPIO number for that button. Next, it is opening a file called value. Here we are getting the file descriptor for that file. So it will open that file, which is in /sys/class/GPIO along with number and value. Next, it is checking if that file descriptor is less than 0. So if it is less than 0, then error has occurred, and if everything is alright, so then it will return the file descriptor. Let's come back to that function. So it will save all the file descriptors for the button, and then it will return to the main class. Then after this function, it will call a function called ground floor. So initially the lift will be at the ground floor, so it will set that LED. So where is it? Ground floor. It will set the position LED for the ground floor, and it will be 1. So position LED is the green LED, so this will be set initially. Next, it is coming back to the main function, and in main function, now the main part of the code comes, which is getting the input from the user. So next, it is declaring a integer, and it is assigning that integer to current. So current is 0, so temp is also 0. Now it will enter into a infinite loop, and it will call a function called for the new to get the new floor, to get the button input from the user. It will call a function called get floor. Let's go to get floor. So it is declaring a integer called RAT. It is initializing it to -1. It is also declaring a integer called MTS. Next, it is calling a function called seek button. So let's go to seek button. Now in seek button, this is a function. This is a predefined function, which is called fd_0. So what this will do, we have declared a file descriptor set initially, which was read_fds. So it will contain a set for the file descriptors. So for initially, what this will do, this will make all the bits in the read file descriptor as 0. So all the bits for FDS are 0 now. Next, it will initialize maximum file descriptor as 0, and it will enter into a for loop. Now in for loop, it will set the bits in the file read FDS. So this is a structure which has bits for file descriptors. So it will set the relative file descriptor bits as 1. So for first file descriptor, which is for the ground floor, it will set that file descriptor value in the structure to 1. Next, it will check for the second floor, and it will set the value for the file descriptor as 1. So it is a set. It is actually a set, and it is setting the bits for the file descriptor. It will compare the file descriptor number in its set, and it will set that value. Next, it is coming into the if, and it is checking the maximum file descriptor of the 4 floors, and it is setting that value to my max file descriptor. So we are doing this because we are using a monitor called select. So in that monitor, it will monitor all the file descriptors, and it needs an argument which is the file descriptor, maximum file descriptor, and it will monitor all the file descriptors which are below that. So for that, we need this maximum file descriptor, and it is setting it to the maximum file descriptor of the 4 floors. Next, we are coming down and we are doing this lseek. So lseek will set the offset for each file descriptor, and this is a standard function, and it is setting the offset as 0 for the file descriptors. Next, we are reading the file descriptor, and we are taking the value into this buffer. So we are taking 1 byte into the buffer. Next it is returning to the get floor, and we have used this max underscore FDS. So in this it will be used. So select is a monitor which will monitor all the file descriptors, and it will monitor all those file descriptors which are below this maximum +1. And then this is null. So this is to check whether some file descriptors are ready to read. So if there is a file descriptor which has some data, so if it is ready, so we can read from that file descriptor. So we have taken it as null. Next, for this it is to check if the file descriptor is ready to write. It is ready to be written to that file descriptor. Again, we have taken it as null. Next, this argument is to check if the file descriptor is ready to, if there are some errors, and if handling of that error is pending. So we have passed argument, we have passed the set, the read underscore FDS set to this, and what this will do, it will monitor all the file descriptors, all the 4 file descriptors, and if the user has entered to one of the file descriptors, if I have pressed the button for the third floor, so what this will do, this will set the file descriptor of the 3rd floor, and it will unset all the other file descriptors. So only the 3rd floor's file descriptor will be 1 in the set, in the read underscore file descriptor set, and rest of them will be 0. And this is for the timer. So we have taken it as null. Next it will come and it will check for the errors. So if there is some error in the file descriptor, so it will check here, it will return the file descriptor to RET. It will check if it is less than 0, and it will report as error. So next it is checking for the floor, so which floor has sent the request for the lift. Next it is taking file descriptor for each and every floor, and it is checking if the bit is set in this set, read underscore FDS set. So now I have pressed the 3rd button, so only 3rd button's file descriptor will be set in this read underscore FDS, and it will return a non-zero value if the bit is set. So then what will happen, then it will set the floor LED, which was the red LED, to 1. This was in the structure, and then it will sleep for 1 second, and it will return RET. It has, so J will be 3 in this case because I have set the 3rd floor, and it will return to the main class. So here new floor will be 3. Now it will check if new floor is less than 0, so which is not possible. So it will continue in that case. Next it will compare the current position with the new position. So current position was 0 and new position is 3. So the condition is satisfied, so it will come inside. So actually no need for this line. Then it will come inside, and it will check while the current position is not equal to new floor. So if the current is new, then it will come out of this loop, and it will call a function called go up. Let's go to go up. So in go up, it will show the direction of the lift. So it will set directional LEDs as 1. It will start from 0, which is in the ground floor, and it will go to the topmost LED, which is the 7th LED. Next it will use sleep, which is in microseconds, and it will sleep for this much time, this much microseconds, and after setting the direction, it has to unset all those LEDs from the ground floor. So this is what is happening in the go up. Next, let's go to the class. The control will again come to the int main, and it will sleep for 100 microseconds. Then it will increment the position of the green light. It is incrementing temp, and it is setting that value to 1. Then it is sleeping for this much microseconds, and it is assigning current as temp. So initially temp was also current, which is here. It was 0, so now it is incremented to 1. Now current will also be 1. It will see for 500 microseconds. Again it will compare if 1 is equal to 3. So currently we have our new floor is 3. So the condition is not satisfied. So it will the condition is satisfied. In fact, it will again come inside and it will call go up function. And again go up will show the direction of the LED, and it will unset the direction of the current position, which was that in the first floor. It will increment temp and it will set the LED for the second floor. And again current will be second. It will check for the validation of the condition. Then again the condition is valid. It will come inside. It will go up. It will show the direction, and it will do the same thing. And after this, the temp will be 3. The current will be 3. It will check if the condition is satisfied. No, this time current is equal to new floor. So it will come out of this, and it will finally unset the value for the position which we have set in this function. In this function we have set the direction of the red light as 1. It will unset that value. It will return. Suppose my lift is at 3rd floor and I am calling it to 1st floor. So what will happen in that case? So new floor will be 1 in that case. Then it will check if current is less than new. Now new is 1 and current is 3. So the condition is not satisfied, then it will go to else. Now in this case the current is more than new, so it is 3 is more than 1. It will come inside. Now it will continue on it until temp is not equal to new floor. So it will call a function called go down. It will go down, and it will start from 7, so which is the topmost LED, and it will glow all those LEDs and will sleep for this much microseconds. Then it will unset all the LEDs, and it will give an effect of going downwards. So the lift is going downwards. Then it will decrement the temp, and now temp was initially it was 3. So we have declared it as 3. So here it was 3. Then it will decrement, and it will set the value for the position LED, the green LED, as 1. Then it will so no need for this actually, but we are using it because we have used it in the first function. Then it will check if temp is not equal to new. So now it is 2. It's decremented. The temp is decremented to 2. Now the condition is again satisfied. It will come inside. It will decrement temp, and this time it will become 1. So condition is not satisfied. So it will come out of this, and it will again unset the value of the current position, the red LED. So this is what the code is. Now let's see the execution for this program. So you can see it is going upwards. The green position LED is going upwards. Finally, after reaching this, it will unset this LED. Then it is coming downwards. So you can use, you can directly copy paste this code to the Beaglebone and run from there, or you can use some IDEs. So V3 Igniter is a good IDE for this, and you can use many IDEs. There are many IDEs in the market. So this is how it works. Thanks for watching, guys, and do subscribe.